Hello and welcome back to this amazing channel. This is Abhinav. So today in this particular video, we'll discuss about the problems of Leetcode contest also. We'll discuss about the Leetcode weekly contest 394 and we'll discuss all the 4 problems of this particular contest. So yeah, I was trying to make videos of this and yeah, today we will record the video of this 394. So the very first problem is we have like basic these 4 problems. These first 2 were of kind of a easy level. This was a medium problem of dynamic programming, and this fourth one is a problem of graph Dijkstra algorithm basically, where you have to find the shortest path between 2 points. That was a straightforward problem with a simple, some customization was there, right? So let's discuss all the problems one by one. So these first 2 problems are very interconnected. So we will discuss both of them, at the same time. So the problem is that you have to count the number of special characters. So what are special characters? So you are saying that a letter is called special if it appears both in lowercase and uppercase in word. Right. This was the problem number first. If you will see the second version of this problem, it says that again you have to count special characters, and here it is saying that a letter is called special if it appears both the times, means lowercase also uppercase also. That's the first condition. And one more extra condition is added is that every lowercase occurrence of C appears before the first uppercase occurrence of C. So basically the thing is a letter which is present both lowercase and uppercase, and lowercase letters or lowercase occurrence of that character of that letter should present before the uppercase occurrence. That's the basic thing, right? For example, you will see if here you will see A is present. So first of all, two small a's are present, then the capital A is present, means the uppercase occurrence is present after the lowercase occurrence. So A is a special character. Similarly, B also you can see, C also you can see. But if you will see here, you can see B is not a special character. Why? Because in B there is a lowercase character after it also. So the basic agenda is that both lowercase and uppercase characters should present, and lowercase characters should be present before the uppercase character. That's the basic thing. So if you will see how I have solved this problem actually. So let me close this. Yeah. So if you will see what I will do for each character. So we have 26 characters, right? From A to Z, and which basically from 0 to 25. Okay. So for all the characters which are from A to Z, I will run a loop first of all. Okay. Now, first of all, I will find the first occurrence of its uppercase. What's the first occurrence of the uppercase of that particular character? Okay. So I will simply iterate in that word, and whenever I will get the uppercase of that particular character, so I am making A plus I. So whatever is I, when I will be 0, it will be A. When I will be 1, it will be B, C, D, E. So this is how what I am doing is I am finding the first occurrence of the uppercase character of this ith index, right? So when I is 0, that basically means we are talking about A. When I is 1, we are talking about B. Up to when I is 25, we are talking about Z. I hope this is clear to you guys, right? This indexing is clear. So what I'm doing, for example, if we are given with a string S, okay, which is let's say B, A, Z, B, Z, B, C, C. Okay, so what we will do? One by one, we will check for all the characters. So see, if you will index this particular string, what will actually happen is that first of all, you will find the first occurrence of the uppercase character. You will find the first occurrence of the uppercase character, so which is the first occurrence. Then you will find the last occurrence of the lowercase character. Okay, and for all the characters you will do that. First of all, let's do it for I is equal to 0. That means for A. So what's the what's the first occurrence of capital A? So first occurrence of capital A is 3. So the first occurrence of capital A or the uppercase is 3. Now you will find the last occurrence of the small a, you can say, right? The last occurrence of small a is 1. And what the condition was? Condition was that uppercase character should present after lowercase. And you can see here, uppercase is present after lowercase because its value is greater. That means A is a possible answer, right? Similarly, let's check for B. For B, if you will see, when you will find the uppercase occurrence, the first uppercase occurrence, it is 2. But you will see that there will be no lowercase occurrence. That means it cannot be a special character, because first of all both should be present, and then the next condition is that lower should be before upper, right? Now similarly let's check for C. So for C again you will see the uppercase is here, lowercase is here, which is smaller, means C is also a possible thing, and then Z is also a possible thing. This is capital Z, okay? So answer will be 3. So what I'm doing here is, for each character from A to Z, I'm first finding the first occurrence of its upper character, then last occurrence of its lower character. Now if first of all we will check that both upper and lower characters should exist. First of all, if the first occurrence of upper character is not equal to -1, that means if it exists. Similarly, if last occurrence of lower character is not equal to -1, means lower character also exists. So this basically tells us that lower and upper characters both exist. Now next we will check that the upper occurrence should be greater than the lower occurrence. Why? Because upper characters should be after lowercase characters. And if all these conditions are fulfilled, we will say it's a special character and we increase our answer and then return the answer. That's the simple thing that we are doing here. And this is the second version, right? And in the first version, nothing different. I have used the exactly same code. If you will see here, exactly same code. Only thing is we don't have to check for this last condition. Means here they are not asking us any such condition that the lower should be before upper. Here they are just asking that a special character is a character where both upper and lower case exist. Simply check if there is a occurrence of uppercase and if there is a occurrence of lower case for the character, simply increase the answer. No need to check for this third condition. That's it, right? So the same code I have used for both problem number A and problem number B, right? I hope this is clear. So this was the first problem. I hope you have got the complete understanding of it. Still, if you have any doubt, you can comment down, okay, and ask your doubt, or you can join a Telegram channel to basically ask your doubts, right? Amazing, amazing. Now moving forward, next what we will actually do is we will solve this problem, which is minimum number of operations to satisfy condition, right? Now this is a problem that I have solved using dynamic programming. I'm not sure if there is a better way of solving this problem. If there's a better way, please do let me know, right? So see guys, here what this problem says. So this problem says that you are given with a matrix of size n into m. So let's first of all create a matrix. That's the very first thing we'll do. Okay. Now see. So we will first of all create a matrix. So I'm creating a very random matrix, right, of some size. Let's see what the size comes out to be. I'm not sure. Yeah, yeah. Okay. Yeah, this is better. Okay. So if you will see here, this is 0, 1, 2, 3, 4, 5, 6, 7. This is 0, 1, 2, 3, 4 and 5. Okay. अब देखो कैसे करेंगे हम लोग, how we will solve it actually. You can see there are n is 6, means there are 6 rows and the m is 8. There are 8 columns, right? Up see, initially what I will do is that okay, wait. Debugging this for this large matrix will be a little bit difficult. What I will do, let's remove the 2 rows and 2 columns from the below. So sorry for it, because otherwise debugging this will be very difficult. Okay. Now this is better. Now it will be easy for us to have a dry run and all. So now let's make our n as 4 and m as 5. So this is a matrix of 4 into 5 size. Okay. Now what you are saying is that initially there are some values that are being set into this particular grid. Okay. For example, the values are, and the values will be between 0 to 9. That's also one important thing, that the values that are present in this grid are from 0 to 9. You can see here, right? So it will be like, let's say 2 is there, then we have 1, then we have 0 and we have 2. Okay. Now here let's say we have 2, 0, 2, 2. Then we have 1, 9, 8, 7. Then we have 9, 0, 0, 6. Then we have 5, 4, 1, 2. Okay. Ab dekho, the problem, what we have to do is, the problem is that we have to first of all make numbers in each column equal. So you have to make numbers in each column equal, means for every column the numbers in that column should be equal. So they are actually saying that is, they are actually saying is that for each I, its value should be present equal to the I plus 1. Means for every cell, the value of this cell should be present equal to its below cell. So that basically means that the value of a particular column should be equal for all the cells. That's the basic thing. So we have to basically make, for each column, we have to make the value of all the cells equal to a particular value, right? Second condition is that also for two adjacent columns, the value should not be equal. So the grid I comma j value should not be equal to grid I comma j plus 1. For example, if we will make all the cells of this equal to 3, for example, so we cannot make this equal to 3, right? That's the second condition. See guys, you must be thinking that Abhinav, this problem is very easy. What we will do is, for each column, we will find that which is the number which is present maximum number of times, right? And we will set the whole column equal to that number only. For example, if you will see the column number first, in this column, the number that is present most number of time is 2. So what we will do that, okay Abhinav, 2 is already present 2 times. Remaining, there are 2 more cells which are not equal to 2. I will make them also equal to 2. That's fine. So how many operations we did? We did only 2 operations. And we have to do actually minimum number of operations, right? So here we did 2 operations. But because we have changed this whole column into 2, now we cannot actually change this into 2. Because here also the maximum element is 2. And here even it is present 3 times. So it's better to change this to, to 2. Here you have to just do 1 operation. So how to choose this? Okay, whether to make this one to equal to 2 or this one to 2. Maybe the next was even better. Maybe next was all are 2. We don't know, right? So that's the problem that comes. So in this case, you have to obviously check for all the possible combination. Means we will see कि अगर यहाँ पे 0 put करेंगे, means if we will put 0 here, then what will be the case? If we will put 1 here, then what will be the case? If we will put 2 here, then what will be the case? So we'll check for all the possible combination for each column, right? So what I'm saying, for each column we will see, okay, if we will put 0 here, what will be the possible thing? 1 here, then what will be the possible thing? And that we will do. So what we will do actually is, we will actually create a DP array that will be of size 10 comma m. Why m? Because we have to find it for all the columns, first, second, third, fourth, fifth, and 10 because we have 10 possible values from 0 to 9. There are 10 values, right? Means either we can set a column into 0, either we can set it to 1, 2, or up to 9. So we have 10 possible values, and for each possible value, we will find that how many operations are required to set that particular column to that value. Okay, अब हम क्या करेंगे? Initially, for example, DP is here. Okay, so columns are same now, but only the value, this value is different, right? So for example, I will say 0, 1, 2, 3, 4, 5. Okay, let me make even more closer. So I will say 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so what this basically means is that this is a DP array which has these columns, 5 columns, same as what our grade has, and it has 10 rows basically, starting from 0 to 9. Okay, अब देखो, first of all, for the very first column we will find what we will find. We will find that if we will put a 0 here, then what is the minimum number of operations we need? If we will try to make all the elements equal to 1, then what's the minimum number of operations, and so on. अब देखो, if you will try to make this whole column equal to 0, you will need 3 operations. Why? You have to make these 3 equal to 0. Okay. Similarly, if you have to make this whole equal to 1, you need again 3 operations. You have to make this equal to 1. Okay. If you have to make this column equal to 2, you need 2 more operations. And for all the other, you can see you need 4 operations, because for all the other numbers, they are not present in the column. So we have to make all the number equal to that number if we have to change it to that, right? तो ये हो गया. अब देखो, see, for the first it was fine. We will simply find it. Okay, we will simply find okay, total we have 4 numbers in that column, means we have 4 rows, and minus whatever is the occurrence of the number. जैसे 0 एक बार present है, तो 4 minus 1 3. 1 भी एक बार present है, 4 minus 1 3. 2 is present 2 times, so 4 minus 2 2. That is completely fine. Okay, that is completely fine. Now the problem comes. When the problem comes actually, for second row. Now see, when we will find for a second column, we will not just find for this column. We will take both starting from 0 till that column. ठीक है, अब देखो, see, now the thing comes, for example, if you are trying to make all the elements of this column equal to 0, of this column equal to 0, if you are trying that, right? So how many operations are required? So to make all the elements of this column equal to 0, you need 3 operations, right? Okay. Now you need 3 operations to make them equal to 0. Now you need to also find कि previous से क्या minimum आ रहा था. Means you have to also take care of the previous column. कि what should be there in the previous column. Now see, current column you are trying to change it to 0. So if you are trying to change the current column equal to 0, you cannot make the previous column equal to 0. So previous column should be non-zero. So what you will do, for the previous column, which is this, you will find the minimum apart from 0. कि 0 के अलावा, like I don't want to make the previous column equal to 0. Now if I will not make the previous column 0, what is the minimum case that I can get? So you can see the minimum of this all will be 2. Means if you will make the previous column 2, you need just 2 operations, and then you can also make this column equal to 0. So total operations will be 2 from this column and plus 3 from this column, because 3 is needed to change it to 0. So total you need 5 operations if you need to make it to 0 and make it to 2. Simple. That's the minimum that you can get. Same for 1. Ab dekho, for 1 what will happen? For 1, this will need 4 operations. This will need 4 operations. And now for this, apart from 1, the minimum is again 2. So it will be 4 plus 2, 6. Now let's see that, let's say it wants to make this column equal to 2. Now if it wants to make it equal to 2, so only one operation is required. Change it to 0. Only one operation is required. Now for this column, if you will try to make it equal to non-2, you cannot make it 2. Apart from 2, what's the minimum case you can get? So apart from 2, the minimum you can get is 3. So 3 from here and 1 from here. Overall, you will need only 4 operations. Okay? And then so on we can get. Now for this also, for 3, 4 operations needed here and minimum will be 2 from here, so 6. And for all the other, you will see that it will be 6 only. Because for all the other, you will need 6 operations here, and previously you will get 2 as the minimum. Right? Similarly, you will come here. So from here also what you will do, you will find the same thing. So basically how we are doing it. So if you will see the code that I have written here, what I did is, first of all, I calculated the n and m, how many number of columns are there, how many number of rows are here. Okay, I got first a DP array of 10 comma m. As I said, there should be 10 rows. For each value you will find for each column. So 10 comma m, there are m columns, right? Now first of all, for each column you will do what you will do for each column. So we first of all had a loop for each column which will iterate from 0 to m minus 1, right? Now for each column you have to see that, okay, कि अगर 0 put करेंगे तो कितना होगा, 1 put करेंगे कितना होगा. Means for each value from 0 to 9 you have to check, okay, if you will try to make that column equal to 0, how much operations you need. If you will try to make that column equal to 1, how much operations you need. That is what you will do, right? So first of all, this is the column number and this is the value number that you wanted it to be. Means you want to make this column all the values equal to this value, right? Up, what we will do, we will see that in that particular column, for all the rows, how many times this value is present, which is called x. So हमने x निकाल लिया. For example, we will say, okay, in this column 0 is present 1 time, 1 is present 1 time, 2 is present 2 times, and so on. So for each value, how many times it is present in that column, that we will find. अब देखो, if it's the very first column, if it's the 0th column, then nothing to do. जो भी आपका आउटपुट है, for example, you will say, okay, 0 is present 1 time here. That means 3 operations are required, which is n minus x. मतलब 4 minus 1. Why? कि it is present 1 time, means for the 3 remaining value, you have to change it to 0, right? So if the column is 0, your value will be simply dp of value, means for this particular value, for this particular column, n minus x operations are required. Why? Because total there are n values in that column and x values are equal to value. So remaining values we have to change it to value. Means this much number of operations are required, right? Now when column is not 0, just like we got it for this column, for the column number 1. For column number 1 what we will do, or for all the other columns what we will do, We will first of all take, okay, mn. So we will find the mn of all the values of the previous column. For example, just like if you will see, हमें जब ये निकालने क्या किया था, okay, yeah, or let's say if we have to find the value for this, तो हमने क्या किया था, here the value was 0, means we were trying to set the whole column equal to 0. Okay, so first of all we know that to make this whole column equal to 0 we need n minus x operations. That is always there. Using this n minus x operation you can make this whole column equal to 0, which are actually 3 operations in this case. आपको 3 operations लगेंगे to make this whole row equal to 0. Now thing comes, if you will make it equal to 0, you cannot make the previous column equal to 0. So previous column should be anything other apart from 0. So apart from 0, what's the minimum value that you can get from the previous column? That is 2. That was 2. So basically this means that you need 2 operations from the previous column and 3 operations from the current column. So total you have 5 minimum operations if you have to make this to 0 and previous to 2. So what we did is we are finding for the previous column, means for column minus I, for all the values which are not equal to value, we are finding the minimum of that, and final value of that column will be n minus x, obviously the operation required for that column, plus the minimum of the previous column. That will be a value. And this is how you will find the DP array for all the columns, not just this. So you can find it like for others also. Let's do one thing. Let's maybe remove this. Just let's check for this one more column. So what we will do, अब यहाँ पे क्या होगा, let's make some more changes. Let's say इसको हम कर देते हैं 1 and 1. So here we will see, first if we will try to make all the elements to 0, so 4 operations are required, and previous you cannot make 0. So apart from 0, minimum is 4 here, and here also you need 4 operations to make it 0. Output will be 8. Ab next, if you will try to make this row equal to 1, you need just one operation, and previous you cannot make it 1. So apart from 1, the minimum is 4. So overall you need 5 operations, and so on. And you will see यहाँ पर 1 ही करेंगे हम, तो minimum you will get will be 5. So 5 will be your answer. Here only 5 operations are needed. How 5 operations are needed? This is how you can do it. What you will do actually is, one operation will be, you will make it 2. Second operation will be, you will make it 1. Third operation will be, you will make it this. So you will see that only 5 operations are there. This all became 1, this all became 2, this all became 1, and so on, right? So this is how you will find the minimum of the value of DP of the last column. So iska jo bhi minimum hoga, that will be your answer, right? So this is how we have solved this problem. I'm not sure that if there can be a better approach for this problem, because this is what I thought of and I implemented. If you guys have any better approach for this problem, do comment it down. Or also if you have any doubt, that you can also ask in the comment section. And please do join our Telegram for more discussions and your doubts, right? Amazing. So that's the thing. Cool. So that's what the problem number C. Now let's discuss the last problem for this particular video, which is actually find edges in shortest path. Okay, this is actually yeah. So this is actually a hard problem, hard difficulty problem. It is of graph. So let's first discuss this problem. So guys, first of all, in this problem, you are given with a undirected weighted graph. Okay, it's a undirected weighted graph. Directions are not there, and every edge has a weight, right? That's the thing. Now you are given, what you are given with? You are given with a vector of edges, where each edge contains the 2 nodes from which to which the edges and the weight of that edge. Okay, and it also contains the number of nodes in the graph, right? Now what you have to find is, you have to find the shortest path from node 0 to node n minus 1. You have to find the shortest path, and actually all the possible shortest path you have to check, that they are asking. Now you have to find that if a particular node lies in any of the shortest path from 0 to n minus 1. If it is lies, make that particular index true, else make it false, right? So this is the case here. Ab dekho how we will solve this problem. It is actually a difficult problem, and what we have used here, a Dijkstra algorithm. Obviously Dijkstra algorithm will be used to find the shortest path from 0 to n minus 1, and then we have used the DFS actually to find that for a particular node, if it is can be possible, in a particular way or not, right? So that is what we will do. So let's discuss how we can solve this problem. First of all, let's have this. Okay, wait. Yeah, let's have this graph only. Okay, it's better. So this is the graph that we have here. Ab dekho, see one thing. What we will do, first of all, we have to find Dijkstra. So I hope that you guys know how to find Dijkstra algorithm, but still I will tell you. To find Dijkstra, first of all, what we did is, we first of all uh, is build a graph. So for graph, what we did, we have taken a vector of vector, because for each edge actually, we have to store three things. First thing you have to see, okay, for example, there is an edge u, also node u. So first of all, you have to find that, okay, from this node u, there is an edge to node v. That's the first thing. Then you have to store the weight of that particular edge. So there is an edge from node u to node v, and the second denotes the weight of that particular edge, and this I actually denotes the index of that particular edge. Why this index is important? Because you have to actually tell that for each edge whether it exists in the shortest path or not. So we have to actually return the answer in that case only. So we need to store the index for each edge, right? That's the next thing, next important thing, right? So this is how we are storing our graph with three basic values for each pair of nodes, right, which represent the edge. So this is a simple build graph that we have did. I hope this should be clear. Now next is the Dijkstra algorithm that we are actually, using here. This is the whole code for Dijkstra algorithm. I hope that you guys know at least Dijkstra algorithm, but again I will tell you how to do it. So what we did here is, in Dijkstra algorithm, we take actually a priority queue, right? So we do take a priority queue here, like this, and it's a min heap priority queue. Minimum means the value with the minimum comes at the top. So we have taken a min heap, right? You can see it's a min heap priority queue that we have taken of pair actually. Now what does this pair represent in this priority queue? So this pair represent distance comma node. So what does it mean? It means that initially we will store 0 comma 0 here. So this basically means that because you have to find from 0 to n, you have to find, right? तो हम क्या कर रहे हैं यहाँ पर? We represent here that this is the distance and this is the node. That means कि to reach node u, this is the minimum distance that you have to need. Not the minimum distance, means to reach node u, this is the distance that you need for that particular pair, right? This represents distance and this represents the u. So initially we inserted 0 comma 0 into the priority queue because we know that to reach node 0 we need 0 distance. That is inserted, right? Now we also have one more vector that will actually tell the minimum distance to reach a particular node. This is the actual that will store the answer. So it will be equal to the size of how many nodes we have. So because we have 6 node here, the size of this distance vector will be 6. So 0, 1, 2, 3, 4, 5. I think it's greater. 0, 1, 2, 3, 4, 5. Yeah, this is not required. हाँ, okay, ये हो गया. अब initially what we will do, we will make all of them as int max, or we can say infinity, just like we do in the extra, okay? But we will make distance of 0 equal to 0. Why we will make? Because we know that distance for 0 is 0, just like we inserted here, okay? Now what we will do is that we will run a while loop while our priority queue is not empty, okay? Now in each iteration, what we will do, first of all we will find that what is at the top of this priority queue, and we will get the distance and the u node from this priority queue. Distance will represent that what is the distance required to reach u. That is what it is saying. Okay, now see, if this distance which this particular priority queue element is saying, if it is greater than the current distance present in our distance array, means we have already found a minimum distance, means we already have a minimum distance to reach u, means this distance is not required. To simply continue, no need to check anything for it. Else, if that distance is actually currently smaller than the distance u, then we will do this particular loop. So what we will do, we will actually iterate through all the adjacent nodes of this u, of this node u, And for each adjacent node, you will try and check what's the distance from that node to V. So for example, currently you will see this is the element in our priority queue. So means our D will be 0 currently and U will be also 0 currently, right? Now you can see this D is not greater than, this is not greater than our D distance I, okay? Distance U. So कोई दिक्कत नहीं है. So what I will do now, we will not check the adjacent nodes of O. So adjacent nodes of O are 2 and 4, right? So first of all, what we will do, we will see that distance, first of all, if distance of V is greater than distance of U plus distance of W. अभी क्या है distance of V? V is, let's say, 2 for now. For now V is 2 and U is 0. अब you will see that distance of V is currently infinity. Means currently we think that to reach 2, distance is infinity. Means we need to reduce it. How we will reduce? Now we will make our distance V equal to distance U plus W. Because what you can do, from distance, from node U, you can actually reach node V with a weight of W, right? With a distance of 1. So हम क्या करेंगे? We will make this distance equal to 1. Why 1? Because we can reach here by 1. We know that. Okay, we'll do it. Okay, and then we will also push it inside our priority queue. So हमने priority queue में इसको push कर देंगे. Okay, now we know that to reach 2, we have a distance 1. Okay, क्योंकि इसके बाद निकालना है. Similarly, for 0 to 1 also we will find. So for 0 to 1 also, if you will see, when V is 1, it is also infinity currently. But to reach here, 4 is a better way. So we will make it 4. Right? And then this will also be inserted 4, 1. Means to reach 1, distance is 4. Okay? Now again we will take the top value of the priority queue, which is 4, 1. Means distance 4, node 1. Up from 1, you can actually reach 4 also, 3 also, 5 also. So we will check for all of that. So initially you can see 3 is infinity. But 3 can be what? 3 can be actually distance of U plus weight. Distance of U is 0. Sorry, U was 1 now. So distance of 1 is 4. And weight to reach 3 is 2. So it will be 6 here. Similarly for 4 it will be 4 plus 3, 7. And for 5 it will be 4 plus 3, 5. This is how, and then all of them will also be inserted in the priority queue, right? So guys, this is how what actually happens is at the last we get for each we get starting from 0 to reach there what's the minimum distance. So this is a smallest distance single source. So single source small distance is this Dijkstra algorithm is, right? So if Milal, so I will not complete this whole dry run. I hope now you guys will get to know. And if you don't know about Dijkstra algorithm, please do check out a video, a dedicated video for Dijkstra. You will get to know about it. Okay, I will not explain the whole Dijkstra here. It will take a lot of time, right? Cool. Ab dekho what will happen here. Once we have the final distance here. Once we have the final distance. For example, if you will see, the actual final distance to reach from 0 to 5 will be actually through here. So it will be 1 plus 1 plus 3. It will be 5. Right? And it can also be from here. So there are actually 2 ways to reach 5. Either from here, either from here. Okay. Yeah. Any other way? Yeah, these are the only 2 ways to reach here. So if you will see in the shortest path from 0 to 4, 0, 1, 2, 3 and 5 are actually occurring. 4 is not there. So if you will see the answer for this test case, all are true. Okay, you have to not check for the nodes. You have to actually check for the edges, which edges are lying in this path. So if you will see, all these edges are lying apart from this edge number, this and this. These 3 edges are not there. So you will see for 3 edges the answer is false. Okay, I think one more edges lies maybe. So if you will see, this is 1 plus 1, 5. Is there any other also way to reach the last node? So one way is to actually start. Okay, let me take highlighter. Start from here, go here, go here. Distance is 5. Okay, next is like this. Here also distance is 5. Here if you will see, so they are saying that this 0, 1, 4, this edge is there. Okay, obviously 0, 1 edge is there. Now they are saying 0 comma 2 edge is also there. So this else is also there. Now 1 comma 3 is also there. Okay, 1 comma 3. Okay, 1 comma 3 we have not taken. Means we are saying that 1 comma 3 edge will not be a part. 1 comma 4 will not be a part, it's fine. And 4 comma 5 will not be a part. But they are saying 1 comma 3 comma 2 will also be a part. How? But how? Because if you will start from here, if you will go here, and if you will go here, and if you will go here, the path will be very large. Hey, it will not be shortest path then. It will not be a shortest path. Consider all shortest path from 0 to node n minus 1 in the graph. You need to find a Boolean array where answer I is true if is a part at least one shortest path. Okay. But there are only two shortest paths. Now, the shortest distance that we are getting is 5, right? The shortest distance that we are getting is 5, right? So 1, 2, okay. How this is not a thing? Actually, I didn't check this test case during my solution. So from 0 to 1, from 1 to 2. Okay, I got it. Sorry, so sorry. So the one path will be like this. So it will be 0 to 1, 1 to 3, 3 to 2, and 1 to 5. Okay. So you can see there are three possible shortest paths. So first of all, see, shortest distance is different and shortest path is different. Using Dijkstra algorithm, we just got to know what's the shortest distance that we have got. So we know that the shortest distance will be 5. Shortest distance to reach from 0 to n minus 1 is 5. That we got. Now we'll check for all the paths that will actually give this shortest distance. The first path is actually this. This is the first path. Second path is this. And third path is this. These are three possible paths. And you can see they are anchoring, like they are covering these all the edges. These two edges are not the part of any of the path. So they will have false. So you can see these both the edges have false. Others have true. Right? Amazing. Ab dekho. Once we have got this shortest path, you can store it here. Up see, if the shortest path is int max, that basically means you can even not reach the last node, because they are saying that graph can be disconnected. So if the graph can be disconnected, that means there is a possibility that you cannot reach the last node. In that case, you will simply return the answer empty because it's not possible, right? All will be false. Else what we will do, we will actually write this DFS function that will take int is the current node, and the second thing is the remaining distance. So we will have two things. First, u will be the current node. Okay, what's the current node we are? So basically what we will try to find with the DFS is, we will try to find all the paths that will have this much of distance and this starting of this particular node. ऐसे कितने path हैं, and in that path also, not just all the path, basically we have to find that in all such paths which nodes are present, because we have to make that node true if it is present in that shortest path, right? So what we are doing is, first of all we are passing 0 in case of u, because we will start from u, and in case of remaining distance we are passing our shortest distance, because हमें इतने distance के path चाहिए, right? अब देखो, if you have reached the end, ठीक है, so I am saying return not of remaining distance. See, first of all, this basically means that, if I will make it easy, if you have reached the last node, that this means that your remaining distance should be not 0. Obviously, if you have reached the last node and you want the path to have the distance equal to this shortest distance, and this basically contains the remaining distance. So once you have reached the end, the last node, your remaining distance should be 0. So if the remaining distance is 0, then I am saying return true, else I am saying return false. So this is the basic means of that not remaining distance, right? Also guys, if you have, let's say, not reached the last node and still your remaining distance became less than or equal to 0, that means this is also not a possible path जो हम ढूंढ रहे हैं, then also return false. Else what we will do, we'll first of all see total rest. Total rest will basically tell me that for that particular u and remaining distance, whether there is a path exist or not. Now for the given u, we will first of all get all the adjacent nodes of u. So v is the adjacent node, w is the weight, and I is the number of that edge. Right? Amazing. Now see, if the distance of v is equal to distance of u plus w, means distance of u plus w is equal to distance v, means that is starting from distance v, if we will move towards distance like means if from node u you will go to node v, जो distance है वो minimum distance of v के equal है, that means that is a minimum path, that is the shortest path. So if it is the shortest path, that means we will make a DFS call from that node. See, from u we have reached v, u से v हम पहुंच चुके हैं, but from v we have to again make a DFS call because we have to reach up to n minus 1 node. So now we are making a DFS call from v. Now remaining distance will be minus w, because w we have got. We have got okay, from u to v distance is w. So that we have separated from a remaining distance, and we will make a DFS call. Now if this DFS call will return true, means there's a possibility, there is a possible path starting from v with this remaining distance. That means that this particular edge is a part of a shortest path, so we'll make it equal to true. Else if this will return false, the answer will also be false. And also we'll make total, we will take the OR of all the value. Okay, if there is all the values are false, that means there is not a possible path for this un remaining also. So finally also will return total rest, which is false. And if there is at least one possibility, if there is at least one true, so this will also be true. That means there was a possible path for this un remaining distance, right? So this was a DFS function. This was the main thing, and then we will return our answer, right? So cool guys, I tried my best to explain this code. If you still have any doubt, please feel free to ask that to me in the comment section, right? Or you can also join our Telegram channel and ask your doubt, right? Cool guys, I will post all the solutions or the solutions of this in the description. You can also check out coding75.com. Oh sorry, where we post all the Leetcode editorials and all. So you can check out the Leetcode daily problems also. And if you want, you can actually check out the Leetcode contest editorials also. So you will get contest editorial of all the problems of all the contests you can see here. You will get all the problems here, right? Cool guys. So that's all for this particular video. Okay. See you guys in the next. See you guys in the next video. Till then, thank you. Take care. Bye bye.